So let's pretend we have set up a new hairdressing business in the town centre and we advertise a special offer to get the word out about our new hairdressers. Now the special offer is £8 per haircut per person for the standard trim, and we get 80 customers a day coming in for the offer. A month later the special offer ends and the price is now set to £16 per haircut per person, and there are now 30 customers a day coming in for the standard trim, indicating that when we reduce our price from £16 to £8, we get an extra 50 customers per day. This means we can expect that for every £1 reduction in our price, we will gain 6 customers per day. Now we want to know what price would maximise the revenue and what would cause our business to earn no revenue. So what we're going to do is we're going to start by creating a simple equation that will calculate our revenue. Now we have revenue is equal to our price times by the amount of haircuts we have sold, which is the amount of customers we have. Now since we want our price to vary depending on how much we reduce our price by, we want to create an equation for price. So we have price is equal to our original price of £16 minus X, where X is going to represent the amount we reduce our original price by. The way this will work is if we reduce our price by £1, then this means that X is equal to 1, which means we have price is equal to 16 minus 1, which is equal to 15. Now we also want the number of customers to vary depending on how much we reduce our price by, as we know that for every £1 we reduce by, we'll gain an extra 6 customers on top of our original 30. So we have customers is equal to our original 30 customers plus 6x. And the way this one would work is if we reduce our price by £1, then x is equal to 1, which means we have customers is equal to 30 plus 6 times 1, which is equal to 30 plus 6, which is equal to 36. So we have price is equal to 16 minus x, and we have customers is equal to 30 plus 6x. Now let's substitute this into our revenue equation, so we have revenue is equal to 16 minus x times by 30 plus 6x. So now if we want to expand the brackets, we would get 16 times 30, which is 480, plus 16 times 6x, which is 96x, minus x times 30, which is minus 30x, minus x times 6x, which is minus 6x squared. We can then simplify this and rearrange, so we would have revenue is equal to minus 6x squared plus 66x plus 480. And we know that if anything is in the form of ax squared plus bx plus c, where a cannot equal 0, then this is classed as a quadratic. So in this case we have a is equal to minus 6, b is equal to 66, and c is equal to 480. Now you might be thinking, how does this have anything to do with finding the best price for our haircut? That won't mean we reduce our revenue. Well, we're going to move over to Desmos to graph this quadratic equation, which will help us to answer our question. So we'll plot our function. We have y is equal to 16 minus x times by 30 plus 6x, and that has produced a curve, so I'm just going to adjust the axis. There we go. So on the y-axis we have revenue, and on the x-axis we have the amount we reduced our price by, and I'll just explain the key parts of the graph. So here where the curve crosses the y-axis, we have the amount of revenue we would make when x is equal to 0, meaning if we didn't adjust our prices and kept them as £16, then we would make £480 in revenue. Now as x increases, meaning the amount we reduced our price by increases, we can see that the amount of revenue we get is increasing due to the increase in the amount of customers we would gain. Now the revenue increases until we reach a certain point, which is the maximum turning point of the curve. So at this point here, the revenue stops increasing and then starts to decrease as x increases. So what's happening here is that we've discounted our price by too much, which has caused us to gain the same amount of revenue as we would have through charging a higher price, even though this means we'd have less customers. Now from this we can know that the maximum revenue we can earn through reducing our prices is at this point here, which is £661.50, which is when x is equal to £5.50. So if we substitute £5.50 into our price equation, we would have £16 minus £5.50, which is equal to £10.50. and that would be the price we can reduce our £16 to earn the maximum revenue. Now some other key parts of the graph is where the curve crosses the x-axis. And we can see here where x is equal to 16 that y is equal to 0, meaning our revenue is equal to 0. And we can also see that the same applies over here where x is equal to minus 5. So this is because if x equals 16, then our price is equal to 16 minus 16, which is equal to 0. And if x is equal to minus 5, then we'd get price is equal to 16 minus 5, which is 21. But we would actually start to lose customers, because if we use the same logic about the amount of customers we would gain for every £1 we reduce by, this also applies when we add £1 to the price. So what's happening here is that we've increased our price too much so that we are losing 6 customers for every £1 we increase our price by. Now obviously it's a little unrealistic to lose all our customers due to the price increase, as I'd imagine that you would have at least some of those 30 customers coming back, but this side of the model is much more realistic, as you would gain more customers through reducing your prices while still providing a haircut to the same standard, so the same standard you'd get if you pay £16. So that's it for this example, but I hope I've given you a useful example of how we could use quadratic equations outside the classroom. There are literally millions of ways quadratic equations are used in the real world, from building bridges all the way to predicting where a ball lands after a cricket player's hit it. Now I don't expect you to fully understand how we form the quadratic equation in this example, but the questions you'll be asked will be way easier than this. Just make sure you check out the examples videos where I go through lots of different examples of the types of questions that you might be asked in your exam.